Let's practice some systems of linear equations problems. Question number 1. X plus 2y equals 13 represents your first line. And this here, 3x minus y is equals to negative 11, represents your second line. Is negative 1 comma 7 a point of intersection? One way to do this is to simply use substitution. Let's substitute in the x value and the y value into equation number 1. So we'll call this equation number 1. Our x value is negative 1 plus 2 times the y value, which is 7. And the question we're asking is, does the left side of this equation equals to the right side, which is 13? So we'll say right side equals 13. Left side is equals to x plus 2y. And we have to see if indeed the statement is true. Let's independently verify this statement by saying left side equals to negative 1 plus 14, which indeed is 13. As we can see, left side equals right side. So indeed, this point appears to be on this line. But the question is it actually on this line and this line as well? So we need to continue to verify this point into this second equation. So we'll say left side is equals to 3x minus y, and right side is equals to negative 11. And again, let's substitute in x comma y. Left side is 3 times negative 1 minus 7, which is negative 3 minus 7, which is negative 10. So unfortunately, left side does not equals to right side. So therefore, even though this point is on the first line, it's not on the second. So we say no, it is not a point of intersection. Why don't we try graphing this on Desmos? So as you can see, this point, negative 1 comma 7, is indeed on one of the lines, the red line here, which is x plus 2y equals 13, but it's not on the blue line. So therefore we say no, this point is not a point of intersection. The true point of intersection should be a decimal number, negative 1.286-ish, comma 7.143-ish. So we use the same technique, substituting x and y into both these line equations, and see if we have a point of intersection. For the first line, we have left side equals 2x minus 4. Right side is equals to 4y, and we substitute. Our x value is 8, and the right side is equals to 4 times y, and the y value is 3. So the left side is equals to 16 minus 4, which is 12, and the right side is 12. Left side equals right side, so therefore we verify this point is on the first line. Now let's try the second line here. Left side is equals to x plus y, and the right side is equals to 11. The left side is equals to x plus y, which is 8 plus 3, which is 11. So indeed, left side equals right side. We verify this point is on both lines, so we call this a point of intersection. For question 3, we're trying to solve by graphing. Let's focus on the first line. We have y is equals to negative x plus 2. We simply threw the positive x over. And so we can see that the slope is negative 1 and the y-intercept is 2. So we have positive 2 is up here. And the slope of negative 1 goes downhill. Let's try that again. For every 1 unit we go down, negative 1, we go 1 unit to the right. So the slope is negative 1 over 1. So this here is our first line, and we want to extend this out as far as we can. It keeps on going and going. And our second line is y equals 3. It's a slope of 0. So y equals 3 is a horizontal line that goes like this. And as you can see, when we go 1 unit up, we go 1 unit left, and the coordinates of the point of intersection is right here. So it looks like the x value is -1. So that's the solution. X equals -1. And if you want to find the actual coordinates of the point of intersection, then we have 1, 2, 3. The actual coordinates are -1, 3. So both answers are acceptable. This here is solving for x, and this here are the coordinates of the point of intersection. Now let's try using substitution. We're going to substitute y equals 3 into here. So we have x plus y, which is 3, equals 2. And throwing the 3 over, we have 2 minus 3. So therefore x equals -1. So this is also another way of solving for x.